be viewed under different dimensions, as most objects can be. However, here we will be talking about two, space and time, although technically that would be four, since when I say space, I mean 3 dimensions, length, width, and breadth. But you get the idea. So let's start off with chaos in space. Objects that behave chaotically in space are called fractals. Chaos is a rather mathematical concept, and there are formulas and that sort of thing for fractals, but a broad definition of the word is an object that does not become simpler as you break it down and study it in smaller parts. You're probably saying right now, I can't think of a single practical thing that applies to this world. But you're wrong, you can, and here's why. We could, of course, look at famous mathematical fractal images produced by formulas and or generated by computers, such as the Cantor set, which is this. You can see that you divide it into smaller and smaller parts as it goes up, and it becomes more and more detailed. You can also look at the Sierpinski triangle, which you can see smaller and smaller triangles. And you can also look at the Mandelbrot set, which looks something like this. However, these aren't necessarily practical in the real world, nor are they really easy to think of off the top of your head, especially if you have not had previous experience with them. So now what? We've exhausted the realm of man-powered, computer-generated fractals that have been painstakingly created and with little application in the real world. Since not even the great race of mankind can make a chaotic object that's practical in a non-virtual setting, then there can't possibly be anything out there, can there? Wrong again. Don't fall into the anti-chaos mindset now, because nature is full of fractals. We actually live among scores of them. You can take almost any object in nature and it will most likely be a fractal, from something as small as a tree, like this tree, or something as big as a coastline, like this. Nature is full of fractals. In fact, you are a fractal. Some fractals have a lot of self-similarity when studying in smaller parts. For example, a tree's branches can tend to look alike one another regardless of how far down you zoom in. Others don't have this property. Take a human body, which remains complicated at even its lowest levels, but doesn't necessarily stay similar. Isn't it ironic, then, that we are in the company of more fractals than not, and yet we learn relatively little about them in comparison to non-chaotic objects? Almost everything we have and will see is chaotic, yet we don't even realize it most of the time.